Welcome to the Quantanix YouTube channel. This is the Next Layer Podcast, episode 16. Today's deep dive. Bias in the code. AI's unseen flaws. Okay. So artificial intelligence, it's become one of the most transformative technologies out there, hasn't it? It's really everywhere, kind of quietly shaping our lives in some pretty profound ways. From the stuff we see online to really critical decisions. Things like healthcare, criminal justice.
Absolutely. It's embedded in so much now.
But underneath all these amazing capabilities, these sophisticated algorithms, there's this really concerning issue, something we're calling the unseen flaws.
Mm-hmm.
And this isn't just some minor technical glitch we're talking about. It feels like a hidden systemic problem, one that really challenges basic ideas of fairness, justice, even human rights.
That's exactly right. And that's what this deep dive is all about. We're going to pull back the curtain a bit. We'll show how bias actually manages to creep into AI systems, sometimes in ways you wouldn't expect, and talk about the very real impacts it's having.
And what we can do about it.
Yeah. Yes, critically, what's being done to address it. Because what's really striking about this algorithmic bias, especially when you put it side by side with, say, traditional human bias, is just the scale. It's enormous.
Oh, so?
Well, think about it. A single person might make one biased decision, maybe a few. But an algorithm, it can affect millions of decisions all at once, almost instantly.
Wow. That scale.
Yeah.
Yeah, that sounds pretty terrifying. Okay, but before we maybe get too far ahead, let's define our terms. When we talk about this unseen flaw, what exactly is AI bias?
Right, good question. So at its core, AI bias is basically systematic discrimination that gets embedded within these AI systems. It's not just theoretical. It actively reinforces biases that already exist in society. It can amplify the discrimination, the prejudice, the stereotyping we already see around us.
Or reflects society's existing problems.
Exactly. And that distinction you mentioned, the scope, that's key. Unlike, one person's bias, which is limited, algorithmic bias works on this massive scale. Millions of decisions, potentially biased, happening super fast. It's like holding up a mirror, but sometimes it's a distorted mirror. It doesn't just reflect. It can actually amplify those societal biases already present.
So they're not neutral tools then?
Definitely not. They're not neutral or objective. They tend to just reproduce these patterns of discrimination that already exist. And the real challenge, these biases can be subtle, hard to spot, but they compound. They add up really quickly into significant discriminatory impacts when a system's making, thousands of decisions every second.
Okay, so if it's not neutral and it can amplify these existing societal problems, where does it actually come from? Is someone deliberately building bias in? Or is it more subtle than that?
Yeah, it's almost never intentional, malicious bias from the developers, which actually makes it harder to tackle in some ways. Instead, it usually comes from several places, often interconnected throughout the whole machine learning process. One of the biggest culprits is what we call data-related bias.
Okay, data-related. What does that involve?
Well, first, there's historical bias. This happens when the data you train the AI on reflects past discrimination. So imagine an AI trained on decades of company hiring data, and those companies historically preferred hiring men. The AI will just learn that pattern. It learns to perpetuate gender bias.
Ah, so it learns from our biased past.
Precisely. It creates this feedback loop, as some sources point out, algorithms blindly using this data without understanding the context, why certain disparities exist. They just reinforce and replicate those discriminatory patterns. It's like giving someone a history book full of inaccuracies. They'll learn the wrong history.
Got it. So the history baked into the data can kind of doom the system from the start.
Exactly right. And then you've got representation bias. This is simpler. In a way. It's when the training data sets just aren't diverse enough. We've seen studies, for example, showing facial recognition systems trained mostly on pictures of white people perform much, much worse when trying to identify people of color.
Because they haven't seen enough diverse examples.
Right. The system just hasn't learned from a representative sample. And then there's also measurement bias. This one's tricky. It's about how the data gets collected and labeled in the first place. The classic example here is the COMPASS system. That's the tool used in some U.S. courts to predict recidivism, the likelihood of reoffending.
Right, I've heard that one.
Yeah, so it often used prior arrests as a stand-in, a proxy for how risky someone was. But that ignores the fact that minority communities often experience disproportionate policing. More arrests don't necessarily mean more crime, but the data looks that way. So the data itself, even if it looks objective, carries bias from how it was gathered.
Wow. Okay, that's subtle but powerful. So it's not just old data, it's how we even collect the data now. Is that it for sources, or is there more?
No, there's definitely more. Beyond the data itself, you also have human bias creeping in during development. Think about the choices developers make. Which data to select, how much weight or importance to give certain features in the algorithm, even the overall design choices. A developer's own assumptions, maybe unconsciously, can shape the output.
So the creator's own perspectives matter.
Absolutely. And then there's algorithmic bias itself. This can come directly from the math, the optimization process. Sometimes models just inherently favor predicting outcomes for the majority group accurately, potentially at the expense of minority groups. Well, it's genuinely complex. There is a systematic review, actually, that identified something like 23 different types of bias in machine learning data.
23.
Yeah, things like selection bias, confirmation bias, group attribution bias, temporal bias, evaluation bias, the list goes on. It just shows how many ways this can go wrong.
23 types.
Yeah, that's
That's a lot to keep track of. Or some, like, worse than others or harder to fix?
Well, it's less about one being worse and more about how they often connect and interact. The real difficulty is that these biases are often subtle. They stem from these bigger systemic issues, and they feed into each other, spotting all 23, let alone fixing them. It takes deep understanding and constant effort. It really highlights how multi-layered this whole problem is.
Okay, so we've talked about what it is, where it comes from, the different types. Now, the big question, what does this actually mean for people? For you listening, where are these unseen flaws actually causing problems in the real world?
Right, this is where it gets really serious, the real-world consequences. And they span across some incredibly critical areas. Let's start with healthcare disparities. There was a major study, huge impact, looking at algorithms used for, I think, over 200 million patients in U.S. hospitals. And it found these systems systematically favored white patients over black patients when deciding who gets extra medical care.
Was race explicitly used?
No, and that's what's so insidious. The algorithm didn't explicitly use race. Instead, it used healthcare cost history as a proxy for health needs. But because of systemic inequalities in access and treatment, past healthcare costs often correlate with race. So lower costs for black patients were misinterpreted as meaning they were healthier.
Oh, wow. So the outcome was biased, even without using race directly.
Exactly. And the impact was massive. The study said this bias reduced the number of black patients identified for extra care by more than half. And we've seen similar documented biases in things like medical imaging analysis and other clinical decision support tools, too.
That healthcare example is just incredibly stark. It really makes you think. If the algorithm isn't using race, how do you even start to figure out why it's making those biased calls?
That's the core challenge with these proxy variables, isn't it? Something seemingly neutral, like cost, ends up standing in for race because of these deeper systemic societal issues. It really shows just how tricky bias detection can be. Then you look at the criminal justice system. We mentioned Compass earlier, that recidivism risk tool. Well, an analysis by ProPublica found a really stark racial bias. Black defendants were almost twice as likely, something like 45% versus 23%, for white defendants to be wrongly flagged as high risk for reoffending when they actually didn't. And conversely, white defendants were more likely to be mislabeled as low risk even when they did go on to reoffend.
So errors were happening, but they were skewed by race.
Precisely.
Yeah.
It's a clear case of these systems potentially reinforcing existing inequalities and having huge impacts on people's freedom, their lives. And then there's employment discrimination. You might have heard about Amazon's experimental AI recruiting tool.
Vaguely, yeah. What happened there?
Well, they trained it on about 10 years' worth of resumes submitted to the company, and that data was mostly from men. So what did the AI learn? It actually learned to penalize resumes that included words like women's, like, say, captain of the women's chess club.
Seriously, it penalized women.
Yeah. It basically taught itself that male candidates were preferable. The algorithm systematically downgraded female applicants. Amazon eventually had to scrap the whole project.
That's just astounding. An AI built to optimize hiring learns to discriminate based on historical data.
Wow. It is. The system did what it was told, find patterns. But the patterns themselves reflected historical bias. And look at facial recognition and surveillance. MIT's Media Lab did some crucial studies here. They found commercial facial recognition systems had error rates up to nearly 35% for darker-skinned women.
35%. Compared to what?
Compared to less than 1% for lighter-skinned men. Huge difference. And you can immediately see the serious problems this causes, right? Especially if law enforcement uses this technology. Misidentification could lead to wrongful arrests. Massive ethical issues.
Absolutely. The potential for harm there is enormous.
And all this brings us to something called the amplification effect. This is really why AI bias is so dangerous. Think about it. Traditional human bias. One person makes a bad call. But an algorithmic bias, it scales up. It affects thousands, maybe millions of decisions all at the same time.
You mentioned that scale earlier.
Yeah, and as researchers point out, if a system's decisions affect many people, an equally big number of people is also potentially affected by discriminatory decisions. And what's even more worrying is the feedback loop. Biased outputs from an AI can then get fed back into the system as new data for future training.
Oh, so it reinforces itself.
Exactly. It creates this self-reinforcing cycle. The bias doesn't just get repeated, it can actually get stronger, amplified over time.
Okay, that's genuinely concerning. Given these impacts, this amplification, what can actually be done? Is there a way to build fairer AI? Or are we stuck?
No, we're definitely not stuck. There are paths forward, but it really requires attacking the problem from multiple angles. It needs a multifaceted approach, targeting different points in the AI's life. One of the most basic, fundamental things is working at the data level.
Okay, fixing the input.
Right. We need diverse, truly representative training data. Organizations have to make a real effort to ensure their data sets reflect the actual diversity of the population they're serving, thinking about age, gender, race, socioeconomic background, all of it. And beyond just getting better data, there are techniques. Data pre-processing methods like normalization, standardization, anonymization that can help reduce bias. Also things like resampling or reweighting to fix imbalances in the data set.
So technical fixes for the data itself. What about the algorithms?
Yes, on the algorithmic side, there's a lot happening too. We're seeing development of what are called fairness-aware algorithms. These are designed to actually incorporate bias constraints right into the training process. They're explicitly trying to minimize bias across different groups.
So building fairness in as a goal.
Exactly. And there's also a big push for algorithmic transparency and explainability, trying to understand how these systems reach their decisions. That makes bias easier to spot. Though it's worth saying this is still really hard for the super complex models like deep neural networks. They can be a bit of a black box.
Right, the black box problem.
Yeah.
Okay, so better data, fairer algorithms. What about once they're actually deployed and running?
Good point. That leads to another critical piece, continuous monitoring and evaluation. You can't just build it and forget it. We need systems that monitor AI in real time, looking for biases that might emerge after deployment. Regular audits, ideally by external experts, are also vital. And something maybe less technical, but just as important, having diverse development teams. People with different backgrounds and perspectives are much more likely to spot potential biases that a more homogeneous team might miss.
That makes a lot of sense. Different eyes see different problems. Are government stepping in at all? Is there regulation happening?
Yes, absolutely. We're seeing growing regulatory responses around the world. For instance, Colorado passed an AI Act targeting discrimination in high-risk systems. The EU's AI Act, which is coming into force soon, is really comprehensive. It sets up strong governance frameworks, including requirements for bias mitigation. California has several laws now about transparency and automated decision-making. And even in specific sectors like insurance, you see bodies like the NAIC issuing guidelines on using AI fairly.
Okay, so there's definitely movement on the legal and regulatory front. That's encouraging. But I imagine it's not easy. What are the main hurdles, the big challenges in actually making AI equitable?
Yeah, you're right to ask that. We absolutely have to acknowledge the challenges and limitations. It's not straightforward. For starters, just defining fairness is incredibly complex. What seems fair mathematically for one group might negatively impact another. There are often trade-offs.
Trade-offs with what? Accuracy.
Exactly. Sometimes improving fairness on one metric might slightly reduce the overall accuracy of a model, forcing difficult choices. And technically, detecting bias in those really complex black box models is still a major hurdle. Plus, implementing all these robust mitigation strategies takes resources, time, money, expertise, which can be tough, especially for smaller companies. And of course, AI technology moves so fast, regulation often struggles to keep up, leaving potential gaps.
It sounds like a constant balancing act.
Yeah.
So looking ahead, what are the key things we need to focus on? What are the future directions?
Well, I think the absolute key is interdisciplinary collaboration. This isn't just a tech problem. We need technologists working hand in hand with ethicists, lawyers, social scientists, people who understand the specific areas where AI is used. Standardized ways of reporting bias would also be huge, making things more transparent and holding companies accountable. We definitely need continued investment in research, finding better ways to detect and fix bias. And global cooperation on ethical standards is important too, so we don't have vastly different rules everywhere. And finally, just basic education and awareness for developers building these systems, but also for the public, for users, so everyone understands the potential issues and demands better. It really has to be a societal effort, not just a technical fix.
Right. We've covered so much ground here where bias originates. It's pretty scary real-world impacts and this whole range of strategies trying to counter it. As we sort of wrap this up, what's the main thing, the single biggest takeaway you want our listeners to leave with today?
I think the biggest takeaway is just how significant this challenge of AI bias really is. It's arguably one of the most critical issues we face as AI becomes more powerful. These unseen flaws aren't just, technical bugs. They're often reflections, symptoms of deeper inequalities that already exist in our society, inequalities that AI systems can accidentally learn and then, crucially, amplify.
So it loops back to us, to society.
It really does. Addressing AI bias means recognizing, first and foremost, that this is fundamentally a human problem reflected in our tech. As many researchers stress, bias isn't inherent to AI, it's inherent to humans, and computers learn from us, so the biases they show, often they're just mirroring our own.
A tough mirror to look into sometimes.
Indeed. And moving forward requires constant vigilance. It requires continuous monitoring, proactive steps throughout the whole AI lifecycle. Success isn't just about clever code. It demands these broader societal commitments to equity, to diversity, to justice. Only by tackling it on all those fronts can we hope to make AI systems that actually serve everyone fairly.
And the stakes seem incredibly high.
They are incredibly high. As AI gets woven deeper into really critical decisions, health, justice, jobs, the cost of ignoring bias just grows. It grows exponentially. Really, the time to act is now. We need to prevent these unseen flaws from becoming permanently baked into the systems that are literally shaping our future.
A powerful call to action. Thank you for that deep dive. And thank you for joining us on this deep dive into bias in the code, AI's unseen flaws. Remember to like, subscribe, and stay tuned for more deep dives on the Next Layer podcast at the Quantanix YouTube channel.